This is cycle 1, week 19, crystals experiment. This is how I would do this week. This is the second 6-week portion of the cycle, and this is where we get back to doing hands-on science. And that is really cool because hands-on science is what this is all about. We need to understand as tutors that the Van Cleve experiments are great, but they're very demonstration based. Different parts of them may have parts where kids are more involved, but in general we're showing the children the scientific principles that are involved. Now that we're doing hands-on science, the kids get to actually do the science with their own hands, which is the cool part, but it means the kids are getting to do the science with their own hands. And they don't necessarily know what they're doing. The little kids are going to have different challenges. The big kids are going to have different challenges. The little kids may not be able to do everything with, you may, as a tutor, may have to be more involved. The big kids may think that they've messed something up if it doesn't go exactly right. So as we move into this section on hands-on science, we want to emphasize to the kids that there is no such thing as messing up science. That's often how we learn. The goal is that we're learning. As long as we're doing that, then there's nothing wrong. We can clean up messes. We can fix mistakes. As the tutor, you want to mitigate those opportunities, but that's what we do. We want to steal Bob Ross's line. We just make happy accidents. We don't have actual mistakes. This week's experiment is one that does require a little bit of advanced prep. In that way, it's a lot like the baby bean experiment. I suggest that you make some solutions the day before or a couple of days before you come to class, and then you let the kids make the same solutions in class, and we'll kind of talk about that. I would add 2 extra solutions to this week. In the Foundations Guide, they recommend Epsom salts with warm water. I would also do granular sugar solutions and table salt solutions. And again, we'll kind of come to that. So the purpose then of this week's experiment is for the kids to get to make some solutions that will form crystals and actually look at them. So on page 129 of the Foundations Guide, we have the scientific method discussion. So what I would do is I would start class with a couple of good questions. I would start with questions like, name a crystal. Again, little kids, you may have to coach more. The older kids may very quickly come up with something like diamond or emeralds or rubies. In general, most people are thinking of precious stones when we're thinking of crystals. And those are crystals. But what we're learning today is that lots of different things are crystalline in nature. And in fact, what a crystal really is it's a very specific 3-dimensional arrangement of either molecules or individual atoms. We want to start with that piece of grammar. I would illustrate it with a pencil. So I would say, what is this? This is the pencil, right? Pencil has 2 ends. This is the eraser. What is this? Some of the kids may say it's the lead. You want to correct them in that. Lead is actually a metal. It's a hard metal. This is graphite. It's often called lead, and sometimes we refer to them as lead pencils because when this material was originally discovered, it was thought to be a form of, quote, black lead. But actually, it's graphite, and you want them to see that. And then you want to emphasize to them that graphite is really made up of carbon atoms. It's carbon atoms that are arranged relatively loosely in 6-membered rings, but sheets of carbon atoms. If you have an example of a diamond that you could bring maybe from a wedding band or an engagement ring, I would bring it in. So I would say this is graphite, which is sheets of carbon, and then I would hold up the diamond. What is this? This is a diamond. Diamond is also made up of carbon atoms. But whereas this is an irregular arrangement of the carbon atoms, the diamond is a crystalline arrangement of the carbon atoms. So it's a very specific 3-dimensional shape and structure. And look at the difference. So other questions then that you could ask, what are the differences between diamond and graphite? Well, one's hard and one's soft. One's translucent or clear and one's black. One is so soft and malleable we use it as a writing utensil. The other one is so hard it forms the highest level on the Mohs scale of hardness. Okay, so vastly different properties, all because of the structure. Because diamond is crystalline carbon and graphite is carbon in loose sheaths. loose arrangements of molecules. So what we're going to talk about then today, hands-on, are other kinds of crystals. And so we're going to, again, we're going to prepare solutions that we can dry on glass or on a mirror, and then let the kids look at it and view it. So this is not for the kids' consumption, except maybe for the older kids, if you have time. But as the tutors, we need to understand just a little bit about solubility. So I have here an empty bag of cane sugar, just granular sugar, right, available commercially. I have here a bottle of water. Okay, this bottle of water is about 500 milliliters of water. This bag of sugar is 1.8 kilograms, it says. So let's round it down. So it's 1.5 kilograms. That's 1,500 grams. Okay, so we need to understand that if we were to take 100 mils, so about 20% of this volume of water, and heat it up to boiling, we could dissolve almost a third of this entire bag inside it. That's how soluble sugar is in water. Table salt has a similar kind of solubility. And so for this experiment to really work well, you want to start with solutions that are as concentrated as you can get them. And that's one of the reasons why I would suggest you do this the day before your community day. So I would take just a pan of water, a little bit of water, and I would pour into it as much sugar as you can, and then I would stir it and get the water to boiling. Then I would add the sugar and then stir it until it dissolves. And if it dissolves, I would add more sugar. I would keep adding it until the sugar doesn't really dissolve anymore. So we make a super concentrated solution, or a super saturated solution would be the technical term. And that's the solution that you want to start with, because we now have an enormous amount of sugar molecules dissolved in that solution, or table salt, sodium chloride molecules dissolved in that solution. So for that part of the experiment, more is more. You want to put as much sugar or as much salt as you can in that water, as much Epsom salt as you can in the water. And then you want to put just a little bit of it onto glass. So a mirror would be a good source of the glass. If you're like me and you just have microscope slides laying around, then that works really well too. For this part of the experiment, less is more. So if I take my solution that's very, very concentrated, and I think about putting a drop onto my glass surface, you could do it with an eyedropper. That would be okay. You could do it with just a straw. But an eyedropper and a straw are relatively large amounts, big drops, and that's really not what you want. What I would suggest is just like a toothpick. I would just dip it into my saturated solution, maybe even let a little bit of it drip off, and when you get just a small drop that hangs, then I would put it onto my glass surface, and then you want it to dry. And so this is the other reason. So there's two reasons why I would do this at home first. Is at home as adults, you can get that water boiling and handle it safely to set up your example crystals. And then also because the drying process takes a while. So I have here a droplet that I produced with this toothpick of pretty concentrated sugar water, and it's been sitting on this glass slide for well over a half hour. And I'm outside of Salt Lake City, where the air is pretty dry. It's relatively arid. So it will take a little bit of time for it to dry. So I would prepare these solutions a day before, let them sit overnight. I think they would dry. If you're in a real hurry, I would get a hairdryer, and you can dry from the back side of the solution. You don't want to blow here because you'll blow your droplet everywhere, and you want your droplet in a relatively confined area to make it easy for the kids to see. But you could heat the underside of it up, and that would also help it dry. So I would prepare the night before mirrors or glass slides with the Epsom salts, the sugar, and the table salt, so that they're dry, so that you can bring them in, so that then the kids can take a light source to shine onto it and a magnifying glass, and they can look at the crystals that have formed. I would do that as advanced prep. So then in class, what I would actually do, though, is I would bring the same materials that you can, except I wouldn't use boiling water. I would use tap water. I would definitely turn it to get it relatively warm, so that the kids can experience it themselves. Because again, this is hands-on science. So I would have a new set of mirrors or glass surfaces. I would bring in the sugar, the table salt, and the Epsom salt, some water, some warm water, and I would talk with the kids about, we're going to explore crystals. I would start with the example of the graphite and the diamond, And then I would move forward and maybe ask some additional questions. Like for the real little kids, you might ask the question, what happens when I put sugar into water? 4 and 5-year-olds may not intuitively understand that it's going to dissolve. The 9, 10-year-olds certainly will. But you could ask, what happens when I put it into water? What happens if I use cold water or if I use hot water? What happens if I stir it or I don't stir it? For the bigger kids, those are more appropriate questions. You could go as far as to say, what if I prepared the solutions in different ways? What if I took the same amount of water, same volume of water, and I put half of the bag of sugar, or a third of the bag of the sugar, or a tenth of the bag of sugar? What kinds of differences would it make in the final crystal structures that we see? What happens if I heat it? What happens if I dry my droplets by adding heat underneath it versus just letting it air dry? Would it form different structures? Those would all be good questions that you could ask. For the research step of the scientific method, it just depends on what the kids know. Again, for the little kids who don't understand that the sugar or the salt dissolves in the water, the research means they just have much more to ask. Right. So for the older kids, they won't be able. They may be able to make some good guesses about what would happen if you heated it up versus if you let it air dry, etc. But those would be things for them to research and potentially learn. The hypothesis is what do you think the answer is to the question that you're asking. So whichever question you're asking as appropriate would be good examples of ways to draw it out. So what will happen if we add sugar to water? Maybe even make a list of the answers that the kids give. Give them a chance to make their best guesses. Emphasize that a hypothesis is a guess that you can test. Right? We're going to make our best guess, and then we're going to find out what actually happens. The experiment step of the scientific method is the cool part. That's where we actually get our hands on in the science. That's where we're actually doing the science. So in this case, taking the water, putting it into separate containers and adding the Epsom salts to one, adding the sugar to one, adding the table salt to one, dissolving them, and then transferring them to the glass slides. For that part of the experiment, I would let the kids I wouldn't tell them that you've brought in the pre-prepared slides. I would let them do all of that. Ask those kinds of questions, set up the questions, potential things that they could research, their hypotheses, and then we're actually doing the experiment. And then, because I don't think your droplets are going to dry very fast, then maybe I would especially for the older kids, I would bring in like a cookie cooling rack. I would set it up between 2 chairs, let the kids lay on the ground with an air dryer, a hair dryer, and just start blowing on the bottom of it, just to get some hands-on experience with doing actual science, realizing that sometimes we want to speed up the drying process. So how can we do that safely? How can we do that so that we're not disturbing our overall result? Those are the kinds of things that we want to emphasize. So, and then if the solutions are, after the kids have done that, as your time is, I wouldn't spend more than, half of your time period, 15 minutes, I guess, about doing that. And then I would say to the students, okay, so our solution, what's going on? Our solutions are not completely dry yet. We need them to be dry so we can move on. So we're going to set them aside and they can continue to air dry, but I have brought in my pre-prepared solutions for you. So bring them in, show them that you're on top of this hands-on science, and set them out. And then I would divide them into 3 groups. And then I would set them up with, you might want to bring some flashlights or smartphones have flashlights on them. You need a light source. And so you don't want to shine your light source in the kids' eyes, right? Maybe have your adults in the room help if you have enough adults, but you want your light to kind of come in at an angle. You want your light to come in orthogonal to the way you're looking down on it. That's what I'm trying to say. So that you can illuminate what's going on there, but you're not in any way shining the light into the kids' eyes, so that then they can see the actual crystal structures here. If you get your solutions concentrated enough, you will be able to almost see the salt crystals or the sugar crystals with your naked eye. Almost certainly you will, as long as your droplet is small enough. But certainly with the magnifying glass, they can begin to see it and see what's going on. So then for the analysis phase of the scientific method, we just want to ask the question now, what happened? What happened for the little kids, what happened when we added the sugar? Oh, it dissolved. That's right. We want to break down to analyze what actually happened. What did you see going on? And then we want to draw our conclusion. So what is our conclusion? Or what happened? The answer is they made crystals. The Epsom salts made crystals. The table salt made crystals. The sugar makes crystals. The kids may be able to see a little bit of difference in the actual crystalline structures of the three. It kind of just depends on exactly how the solutions dry. But those would be things you might emphasize, especially for your older kids. Push them. Well, are they all the same? Are they different? What do you actually see? And then the conclusion. What did we learn? What was our question? What was our hypothesis? What actually happened in our experiment? Therefore, what have we learned? We've learned that crystals exist all around us. It's not just precious gems. It's things like diamonds versus graphite. It's things like crystal structures of sugar and salt, Epsom salts and table salt both. All of those are examples of crystals, and by dissolving them in water and then drying them on a glass slide so that we can look at them, we can see crystals with our own eyes. That is cycle 1, week 19.